some typing.
There may have been some new. Yeah.
My reading of it this morning.
Oh, you read through it already?
Well, I read through most of the changes.
Cool.
His grasp of the English language is rapidly
deteriorated, like
yeah. The baby.
So he will need to send another version to fix the.
Yeah.
Nice.
Well, it's
not a drama.
There's a couple of Windows things I wanted to improve beyond what he did. Yeah.
That's maybe something. Yeah, that's something to say. Like what you plan to do before we get it out of the way.
We built it based by today, and we wanted to split it into 4 bedrooms. So they wanted to
Guys, we should start, I think. Test. Can you hear me? Test. Guest. Can you hear me? Does the microphone work?
Yes.
Good. Okay. Yeah. Thanks for coming, going to Seoul for basically a long trip to come here. As you can see, I'm alone. Derek is not here with me this time, and I'm also for the second hour session. I won't be here either. So Kathleen is going to find a substitute. Maybe she is going to. You are Rich, the substitute, and so we'll sort of see what we can do today, and then the rest will overflow to the other session. But for now, we have a 2.5 hour session. So who could take some meeting minutes? Is there someone who could take some notes about the decisions we make?
I'll actually take minutes for once I don't think you're speaking.
Awesome. Thanks, Mike. Okay. So from the agenda, you've seen that I'm going to start with a short update on where we are in the working group. We have submitted 2 documents to the ISG between the Berlin IETF meeting and this one, which is the authentication method reference values. It's currently in ISG review, and there have been some comments submitted, so those will need to be addressed, but I'm quite positive that we can wrap this up fairly quickly. And also the JWD secured authorization request has been sent to the ISG and is being processed there, so that's pretty good. We are going to talk about the device flow and the discovery, which is a work in progress document. The other document that is further along is the native apps specification. We passed working group last call. I had worked on a Shepherd write-up. It's extremely close. William has done a major update to sort of make the document more readable, so lots of editorial changes. And so I've asked Samuel to do a review, which he posted to the mailing list, which resulted in another update. Mike, John, can you say a few words about the status of that document, the native apps document?
Sorry, it was just distracting me. So
the microphone.
So we're pretty much done. William's on the co-authors on the Michu. We just released an update today I think there may still be a few small things with respect to Windows Universal Applications, UWP or whatever they're called. But the document is largely done, so people should give it a final read. Like I said, there may be one small update, but other than that, we have a lot of positive feedback, a lot of developers who are going through using it and using the open source SDK that we're publishing through the OpenID Foundation. So lots of good feedback, people actually using it in the wild.
So when do you expect this update on this on the API? For
Probably
API?
this week, depending upon timing. So
okay. So how do I unblock him? Does it work now?
Hello?
William, I guess you can speak now.
oh, there he is.
Yeah, hey, yeah, I mean, John's update is pretty accurate. So the major edit was mostly editorial, as you noted, just kind of, after the sort of year that we've been, actually using this practice, kind of just fixed up some of the rough edges. But I'd say fundamentally that it's the same thing. Yeah, and you can also try for Mac OS. We added a loopback localhost option in Oauth, so that's in the spec as well if anyone wants to try it out.
Perfect. Yeah. So the plan is to finish this as soon as possible. It's also a PCP, so if we can go back in a year from now to look at the document and how the landscape has changed, or whether there's some additional need for clarification, we can do that without sort of any major impact from a reference point of view.
There are governments and other people who are paranoid about specs being finalized. So getting this one done and then starting more or less immediately on tracking changes in platforms and stuff, so we can come out with another one in another year is probably the best strategy.
Cool, thanks. So that's good. Any questions on that? No. For an upcoming IETF meeting, so obviously William is not here, as you were able to see.
Everybody can congratulate William on his new baby. That's why he's not here. Well, that's what his wife did most of the work, but you get the general idea.
But we entertained the idea maybe to do a tutorial at an upcoming IETF meeting on how to use the native apps SDK, so you can actually build OAuth apps on Android and etc.
Right. So in GitHub, there's iOS, Android, and some OS X and Windows forks of the AppAuth stuff, plus demo applications and things that people can play with.
Okay. Then we have a couple of other documents on our agenda that we are going to discuss today, so I won't go through them specifically. In terms of milestones, we have been a little bit off with our guesses on how long it will take to finish certain items. So we will have to figure out on how to adjust the milestones accordingly. But I marked the ones that I just mentioned with AMR and char as done. But I will have to reach out to the group on some of the other items to have a roughly correct estimate on when we are going to finish those. For the agenda, so here's my proposal. Let me know if there's some changes that you would like to see. There's today I would like to talk about the device flow. I would like to get an update on the authorization server metadata, or this whole metadata question in general. We sort of got a little bit stuck there. There's the token exchange work that Brian has as a presentation slide. Also some new proposal he put together on using TLS-based client authentication. The token binding work, and Thorsten has today submitted a document that we had been talking about for a while now on sort of the security best current practices. specification, which sort of points to the other documents that we have been working on. So we have sort of an umbrella document. And then we'll continue with that conversation because, needless to say, since it was just submitted, I suspect that you haven't read it yet. So we'll continue that debate in the second session. And there's also we had a debate about the non-token token binding based work, the POP tokens in Berlin, and Justin is going to give a presentation about this, specifically the HTTP signing work. And finally, we will conclude with some ideas about new work that John will talk about. And of course, you're welcome to share your ideas as well. Good. Okay, I will start with since I'm presenting already anyway. So are there any questions on the agenda or any other changes that you would like to see? Any additions? Nothing? Okay, good. We'll start with the device flow document. It's a shorter presentation. So this is one of the working group items that we had adopted earlier this year. It's yeah, you see a couple of authors. So to recall what it's about, for some devices we have the use case where the OAuth interaction is actually specifically the authentication and the consent phase is outsourced to a separate device. So in the common use cases, for example, a TV or picture frame, where you have a great UI, but the user or the input capabilities are limited. And so the way how to address this using OAuth is to basically let the flow bounce to another device, like your tablet or your smartphone, and then get back again to the device where you started it. So this is what the document describes. And there are three open issues which were raised in the reviews and also in the discussions at the last IETF meeting. And I had posted one to the list, and I would like to talk about the other two as well. And maybe you guys have an opinion about it. The first one is about polling. So when, so as I said, the interaction starts with the device client, which may be this picture frame or this set-top box. And when it talks to the authorization server, and the authorization server delivers the code and the verification URI back to the device, the user is supposed to then take that code and the URI and enter it in some browser, and then complete the whole dance. And in the meanwhile, the authorization server sends messages to the device, to the set-top box, to ask them whether the process is actually finalized already. And depending on how long that process takes, this polling obviously needs to keep going, and you need to send the messages at a regular interval. Otherwise, a device behind a NAT will lose its NAT binding. So the question is, are there some other ways that we could deal with this other than polling, which generates some traffic, or is this not an issue at all? And so I posted the mail to the list, and I had gotten somewhat diverse type of feedback, and maybe you have a different experience or some other preferences. So Aaron specifically was sort of pointing out that the current specification with polling is very simple to implement. So he likes the simplicity of the whole exchange. William noted that
Which error?
the Aaron Baraki. Yeah.
One on the slide, Mike.
Say again?
Thank you.
William said that they have, and Google has been using the polling exchange, and it works and it gets the job done. But he was sort of inclined to also have a mechanism that uses more modern sort of application layer protocol behavior, such as HTTP HTTP2 capabilities as an optional enhancement. Simon, who's from Fortrock, they have implemented this specification like some other people in the broadcasting community had done so. And he also likes the simplicity, but interestingly, his view is that for some devices, the HTTP stack itself may be a little bit too much. So he's sort of questioning whether we could maybe come up with something that is simpler than having an HTTP stack. I don't know. And Thorsten pointed out that there's this work in OpenID Connect with the Moderna working group, where you have both pull and push style communication. And maybe you can elaborate a little bit more what that is. I think you want to include a link, but that was broken, unfortunately, at least in my email. So in essence, it's not clear on where we are with this issue. It almost sounds like people are actually happy with the polling as is, and don't need any new functionality there. But if you guys have some feedback on this, it would be great, so we can close this topic.
Yeah, this is Thorsten speaking. Just as an explanation, in the OpenID Moderna working group, we are working on two mechanisms which employ similar communication patterns than the device flow. One is a backend authentication protocol. So the OpenID client sends a back channel authentication request to the OP, and then either polls for the results or gets a push notification. This only works in conjunction with out-of-band authentication, obviously. And there's another mechanism quite similarly that asks the user for user consent on a device, which also can be reached via out-of-band communication. We don't have that much implementation experiences yet. That's why I was very interested in discussion, or observing or monitoring the discussion regarding device flow, and just wanted to point out if there is an implementation, or if there is enough implementation experience which shows that pulling is totally sufficient when it comes to, for example, resource utilization on the server side and implementation complexity on the client side, then it's fine. I would like to learn about that. Then we can also get rid of the push style communication in our specs. That was the main motivation for my posting.
Okay, William.
And one of the other authors is standing behind me in the line. So.
William has a comment on that.
Yeah, I can speak to the implementation experience. So we run this at a fairly large scale. Every single YouTube TV app that where people sign in will use this flow and with the polling. So definitely it works. The only idea I had is, can we sort of basically use the exact same protocol but fit it around an HTTP2 long poll where potentially, instead of immediately returning an error, saying that the user hasn't authenticated yet, we could just, we could potentially hold that connection open, say, for 15 minutes. But otherwise, the protocol could perhaps be exactly the same. The only thing lacking is that no one's actually tried implementing that yet. So it's just theoretical. But definitely the polling works.
So John Bradley. So there are other use cases. Roland Hedberg presented one from Sweden where they're interleaving identity proofing as part of the flow. So the actual response may be hours or days later. So I think in the short sort of time frame use cases, polling certainly works, and that's actually my personal preference, but there may be some of these other use cases where the timing on the response could actually be significantly longer.
So it may be that we actually solve that problem by just returning a quick response saying, the flow is underway, and then use the user endpoint to just get sort of the status.
You should say who you are.
If you want some, sorry, I'm
Butting in.
from the same crap. So I mean, I'm not saying that it's not important, right? But there are potentially other ways we could solve the same problem.
Right. So I think we have to look at, what are the performance, overhead issues of giving the client sort of an intermediate token and having it poll once a day or once an hour for 1 million customers or something versus being able to do a post back. So I'm not actually a big fan of post back, but there are people who seem to believe that that's actually going to be better performing, consuming fewer resources.
So butting in again. So the use cases we were working on is the situation where authentication at the OP is actually a fairly long process, right? You actually do some sort of identity check. It's sort of it's identity proofing as an OpenID Connect flow. And for those situations, let me put it this way. I don't think it's entirely okay to assume that authentication is quick. Authentication processes can be quite slow sometimes.
Leif, are you working? So John was referring to a presentation of a use case. Are you working
There's
with
only
Roland?
4 people in Sweden. They're all working together.
Yeah. It's a small country.
They all know each other. So yeah, it's the same.
But so the question for me is whether we should go ahead in this with this document with the polling approach and then figure out later on what the story is for some of the use cases that you've been talking about. Whether that's maybe a independent problem that we.
It may be, right? It may be that we're talking about, say, OpenID Connect running on top of some asynchronous message bus or something. I really don't know, and it could turn out that we're actually looking at a slightly different way to formulate the same use case, so it doesn't actually become a problem at all. So I don't want to hold anything up. I just want to say that it's not necessarily true that authentication is a quick thing. It's not the authenticating a device doesn't, or an entity doesn't, or a data subject doesn't always, isn't always sort of something you can expect to complete within like a
split second
request response transaction for HTTP.
This is Justin, and it's becoming a little bit clear to me that perhaps these longer than long polling HTTP use cases might just need a different flow. So I think that we might be better served to have this fit its purpose. That I do think that incorporating long polling, like William suggested a minute ago, is a good idea. At least referencing that's a thing that you can do, because that is something that's kind of an implementation detail that you can do on the HTTP server side that tends to be transparent to everything else. But these cases where it might be 3 days later, don't use the device flow. Use the 3 days later flow. I don't even know what to call that. The Easter weekend flow, I guess. It's anyway. Next business day. Okay, there we go. So anyway, I think that I think it makes more sense to address these other use cases with something that's more fit to those purposes instead of trying to generalize this one.
Yep. So yeah, I'm okay with that. I think long polling is fine for this. I think that we've uncovered some use cases for a different kind of flow, but putting it in a separate document that this could use if it was required would make perfect sense.
Leif, can you get together with Roland to write something up about the use case that you have in mind? Is that okay? Cool.
I'm not saying we're not necessarily ready to describe what we have, because it isn't as
No, but okay, that sounds good. So I think from this discussion, it's clear that we just go ahead with what we have now and wait till we get the description of this other use case a little later. Good, perfect. The second thing is the user interface aspect. So as described, there's the authorization server provides this the user code and the verification URI, and then the user is supposed to enter this user code on this other device. So needless to say that ideally from a user experience point of view, you want to provide a code that is easy to enter, maybe also easy to read to begin with, or distinguish the characters from maybe if there's some confusion, maybe some font specific issues as well. And there we are looking for some guidance. Maybe there's some people in this group or in this room even who have some experience with those type of user interface aspects. So it's not necessarily, I think, the core expertise of this group, to be honest, but but I think it would be important to point to relevant literature if that exists. I could imagine that people have already investigated that issue before. So I don't have expertise in that field, so I can't suggest. No, well, asking for that. So if you know some. Yeah, but have you written down the some guidelines, recommendations on how to best sort of provide that user experience? Did you do something? Okay. You could? Oh, okay. So you could potentially contribute some text there? Did I hear that? Yes. Cool. So for the minutes, Dick volunteered to provide some input on this to the user interface aspect of this specification. It's a little bit more, oops, what happened? Okay, this is the animation. So we also had, in Berlin, we had a discussion about what I call an alternative contact mechanism. And let me describe the idea to you in this message flow. So this is how it currently works. So you have the authorization server and the device client. So as said, the user code and the verification URI is sent to the device client from the authorization server after it contacts the authorization server. The device client is this set-top box or picture frame or whatever. And then the device client shows that to the user using this rich display. And then the user is supposed to type it into another device, and then it contacts the authorization server once the data is entered. So that's sort of the current approach, how this is done, how the exchange switches to the other device, and then the authorization server can finalize the exchange with the device client. So that's what is currently described. So what we discussed, I believe that's my understanding of what has been discussed at the last IETF meeting and in conversation I had with folks, is an alternative. And maybe there are other ways to do things, but this was one of them. The user enters a telephone number into the device client, and this device then sends an SMS, which the user then gets, and the SMS contains the user code. This is something very common on devices nowadays that you get, like if you have multi-factor authentication enabled, you often get an SMS with some code. The user types in this code into the device again, the device client, and the user code is then used with the device flow as is with the authorization server to complete the OAuth exchange. So it's a different way to authenticate the user and also get the user's consent for this whole interaction. Very different from what I had shown on the previous slide, but still a possible approach. Maybe there are even other ways to do to make it the experience better and faster overall. The question is, which of those mechanisms, or should we only document one, namely the current one that we have in the document right now, or are people interested to also describe other ways of doing things? Or maybe they need to go into separate documents when there's more experience. That was another question. Oh, William.
I'd be happy if we wanted to put
William, go
this in as like a UI consideration. I think it makes sense. The protocol's the same, so we're just talking about the interface, right? Yeah. So if we document like best practices for, as I guess a non-normative section of like how to display the code, what character set to use, for example, other mechanisms. I think that all makes sense. I don't think we need a new spec just to talk about like how it's presented to the user.
Okay, that's a good point.
John Bradley, there is one additional parameter of passing a user hint from the device back to the authorization server. But other than that, it's close enough. I think we should probably describe it in the same document. I think it's a flow that could be a lot more user friendly, especially if you SMS a whole URI to the person's phone and they just click on the URI to say okay. It could reduce a lot of typing, etc. So I think it's a viable option that some device vendors are going to want to explore.
So what do the others think? Is it like, does that sound right? Document
Mike Jones, without taking any position, is there implementation and deployment experience with the second one? There clearly is with the first.
Is there?
John, I've seen it in the wild, but I don't know exactly whether or not the guts of it were using this flow.
Phil Hunt, just responding to your idea, John, I'm just wondering about, is that a good idea to send a URI via SMS? Kind of.
SMS is evil and should be killed, but the carriers have other secure ways of doing it. So sending a URI by SMS probably isn't any worse than using the SMS with a code in the first place.
Yeah, I do. I'm not sure. I agree with you, and I'm not sure it makes much difference. I always think of when I send a code, there's some other context in play that causes the user to sort of put the two together, and that's what makes it a little bit better. Whereas if I get a URI,
type the URI and then type in the same code doesn't.
No, it's just that if I get a link spontaneously, we're teaching users to click on them, and would there be a problem with a user getting a URI spontaneously from a hacker that causes them to activate something that they shouldn't do? I don't know. I haven't thought this through.
There are probably different security considerations with that. Clearly, the two mechanisms are a little bit different. Thorsten,
I would like to re-emphasize what Mike said. So I would like to know whether our implementation experiences or deployment experiences with the new flow or the extension that John proposed. I haven't seen any. And based on what Phil says, I think this really calls for a threat analysis of this new mechanism, because it changes the protocol. If a client can somehow enforce a certain user ID or something like that, this is a significant extension.
By the way, for the guys standing in the back, there are still some free seats available. So please go ahead, like here in the front and so on. So you don't need to stay somewhere unless you feel comfortable doing that. So I think what I heard is we should check back on the deployment experience on this issue, and I will send a mail to the list and reach out to some of the guys who had proposed this type of extension, and then see where we go. Mike, do we have that? Good. Brian. So the conclusion is on the third issue that I will reach out to guys providing deployment experience. And if we don't have any deployment experience with this, I guess we should not include it. Oh, right. Sorry about that. So the metadata, sorry, Brian. So we have this working group item on metadata, authorization server metadata, and we got a little, I started the working group last call early this year, and it got a little bit stuck afterwards. So there was a little bit of a confusion on what we are trying to do, which led into another document that was published on the resource metadata. And I had asked the group whether we should adopt this document, the resource metadata, I mean, as well. And that was in Berlin, and then there was support for that. And so I sent another mail to the list in sort of being confused a little bit about where we are and how we should proceed with this topic. And I'm still not quite clear. So I would like to, without having any slides, because then nothing has really changed in terms of documents since the Berlin IETF meeting, but I would like to get an idea on where we are with this work and how we should best proceed with it. So here's how I see it. And I can even open the document. As a summary of what this is about. So what it does is, so what you typically have is, you have in Oauth, you have some information that you need to, as a client, you need to know in order to contact an authorization server. And that information is typically contained on the website in some HTML type form. And this document is essentially makes this information available as a in a machine readable format using a JSON structure. That's what it does. And so the question is, and then we have this other document that basically does the same, but just for resources. And so we had this, the question about how should we publish this document, the authorization server metadata, should we publish the resource server metadata, one of them or both of them, and or do we also need, in addition to that, publish security specification, because the concern that was expressed was that this would enable more easily automated attacks, since obviously the data is available in machine readable form. Justin, did I explain what the issue is properly?
Yeah, some of them.
Okay.
So I just wanted to voice my take on those questions, is that the metadata for authorization servers is pretty well defined and established and used in other protocols that build on top of OAuth, namely OpenID Connect and UMA. And I think that publishing that document with just, this is the information about the authorization server, you know, it's in this JSON file, and this key in this JSON object means this particular endpoint or what have you. I think that that's worthwhile and fairly easy to do. Resource metadata discovery is a whole different beast, though, because there are different kinds of discovery that you would need for different kinds of APIs. So, for example, those of you that know the UMA protocol know that it's limited to only being able to protect certain types of APIs because of the dynamic discovery that starts at the resource server. Namely, when you show up without an access token, where do you send someone? And if you don't know which resource, which authorization server you're protecting for a given user, then you don't know how to dispatch that kind of thing. So the different kinds of APIs need different kinds of resource discovery, and I don't think that we'll be able to cover that in a single document. Furthermore, there are some very real security and privacy considerations with resource server first discovery. Security attacks aside, which I agree that automating things for the good guys does often automate things for the bad guys too. But you know, the example I like to give is, you know, say I've got a medical record, and I'm not telling you whose medical record it is, but you go to fetch it and it says, oh, go talk to this one particular authorization server, and you know through out of band information whose authorization server that is, and it's a single user, you know, private system. I just told you whose medical record is sitting there and how to attack it better. So there are lots of subtle privacy things like this with resource discovery that I think it's a much bigger and much harder problem, and that conflating and entwining these two is not going to serve us very well. I think that we can publish AS metadata very quickly and cleanly and move that forward.
Tony Nadlin, I'm not sure that the the authorization server document is accurate enough to move forward with it. It is single tenant based, and that becomes a problem for us in Azure. And I also think that the resource metadata document needs to also be linked here, because if I have a resource, I want to find out what authorization server it winds up getting to, and separating them out creates all sorts of issues for people to understand this. And are we going to have to update the authorization server document once we get the resource server document done? So I don't think that either of these should actually move forward.
Any other views?
John Bradley. This document does actually deal with multi-tenant situations, though Microsoft took a unique interpretation of that with Azure. But I don't think that we're precluding multi-tenant situations. I sort of agree with Justin that resource metadata is more complicated because it may actually be more closely related to the protocol that's using Oauth as opposed to necessarily just Oauth. I think that being able to describe the characteristics of the authorization server separately still has value even without the resource metadata. I think that we have to do other things to prevent reuse of tokens that are given to the wrong resource server, etc. But I think those are other specs, either using token binding, proof of possession, audience restricting access tokens, etc. So I think we do have to address those security things. I think trying to do it in metadata is probably the wrong place to do it.
I will let William speak to that.
Yeah, I think it's very valuable to have this machine readable metadata. Like that's useful for developers when they're configuring their clients. They can configure a client based on just the authorization server. I actually see it improving the security because it's a way for the authorization server to declare and kind of claim what the correct token endpoint is. We don't have a concept of that right now. And I think that's actually a valuable security issue. When it comes to things like dynamic authorization and trying to prevent mix-up attacks. And I think there is a fair bit of proven deployment experience as well.
So William, so you are saying you see obviously value in the authorization server metadata, but what about the resource server metadata?
I don't have a particular comment on that. I don't have an immediate use for it, I guess, but we definitely have a use for authorization service being able to claim like what their token endpoints are. I mean, if you can imagine, when we're talking about like mix-up attacks, if you're going to say deal with like 100 different authorization servers, like bring your own authorization server. How do you prevent people from just registering, the bogus token endpoint to like a legitimate, or mixing up the registration? This is one way you can prevent people doing that, because they just give you the authorization server and then you look that up to see what the token endpoint should be. So I think it's very useful for things like the sort of bring your own authorization server, and that's something that we're looking at the moment. But I don't really have a comment on the other one.
Okay. Thank you, William. Phil.
Yeah, Phil Hunt. So my concern is that as we automate configuration, and these are all dynamic cases that are emerging, as we automate configuration, we make some things better, but we also give a new vector for attackers. And so one of the concerns is if the client has been given a fake resource discovery or is convinced to go to something that's masquerading as something else, and even a proxy, we can convince a client to use the attacker's proxy. If you do this one-sided by only doing OAuth discovery, then everything will validate through and the client will be convinced to now issue and make requests through the fake proxy. Mike and I have been talking about this and trying to sort this out. I think the two discovery specs together do some work in a lot of use cases to link the relationship back and forth. It's a circular reference one to the other. I'm not convinced it yet works for all of the cases. We need more study on that. One possibility occurred to me is that I think that's so important that maybe the two metadata specs should be combined together, because what we're trying to get across is that the relationship between OAuth server and resource server has to be understood by the client to be valid. And if we do just one spec or the other, the danger is if you implement OAuth metadirectory spec, you might be just automating an attack vector as much as you are securing everything else. So that remains my concern. I'm just frustrated that there isn't a clear understanding of the problem and there isn't a clear understanding of what's the best solution. We also stepped back, and Mike made a fair comment that, you know, are we solving a problem people want? Dynamic OAuth is something that I think is emerging, and it will be a problem, but because of the security problems, people are finding a static way to map servers. They're finding other alternatives. It's a lot like the IPv6 story, where we knew that IP address spaces were running out, so somebody came up with NAT, somebody came up with other techniques to avoid this, and that's kind of what's happening in the cloud with tenancies, is we're finding other workarounds to keep things static. But for protocols like UMA to flourish, we're going to have to solve this problem, but it still feels kind of IPv6. Is there willpower to solve it? I don't know. Sorry for the long editorial there.
But in a nutshell, you are saying that both of those documents need to move forward. Is that the gist of it?
I'm saying, I'm saying I can live with that, but we want to make sure that if people do it, they do both of them together, and that they understand that the relationship confirmation is the most important part. If we feel we have to go forward, I'm happy to also wait and to keep figuring out, is there a better way to solve this problem? We've also talked about proof of possession mechanisms can also solve it, but will they be there fast enough?
Well, we have so as you said, the resource server metadata and the resource server or the flow for the resource server metadata discovery is more complicated, and there's you raised some security concerns, and currently we have at least two mechanisms to mitigate them. One is obviously the proof possession / token binding work, and the other one is to have audience restrictions. So the concern, if I correctly summarize it, is that a client could be tricked into getting a token that it hands out to a server, which then reuses it at some other place. Is that roughly the concern?
Yeah, or just that that unexpected proxy is now seeing the data.
Yeah,
it doesn't have to rewield the
right.
token at all. It
Yeah.
can just act as a proxy and copy everything.
Yeah. From what I hear from the previous guys was they wanted to start with the simpler problem first, which is the authorization server metadata, and then in a second phase, because conceptually those are different ultimately, right? Wouldn't you agree?
I feel very uncomfortable because the solution we need might not turn out to be what we have. I think it's far more important to understand that you have the correct set of endpoints than it is to actually have metadata, because metadata might be solved by other means that people already have. But what I think we're trying to figure out is, do I have a valid set of endpoints, both token server, authorization server, and resource server? And how does the client know that? That's the question. Now, whether we express this as metadata or the other, but if you just do authorization server metadata, you haven't answered that question. So I question whether, given that we haven't got an answer yet, if we move ahead, we're just gluing ourselves into a specific solution path, which might be the wrong direction. I just can't say. So I'd like to do a little bit more work, given that people are able to push off the issue in other ways for right now.
Thorsten, I think there's a need for automatic configuration for metadata for both the authorization server and the resource server. I'm still undecided yet whether the currently proposed mechanism for resource server discovery is the right direction. Regarding authorization server metadata, I think it's mature. It's being deployed, at least in the OpenID space, and it's proven to be very useful. So I would propose to move that document forward.
John Bradley again. George Fletcher from AOL, and I've seen a lot of other enterprise use cases where there, in a lot of cases, it's okay for a client to specify what authorization server to use, given that we have JSON Web Token, access tokens, etc. So a client can trust the authorization server, and the authorization server may not have an existing relationship with the resource server. And that's okay if you actually audience restrict the token or token bind it or some other thing, as long as the place the client is sending the token can't replay it someplace else. That's actually a fairly common sort of enterprise scenario. And I'm hesitant to rush forward with resource metadata that may actually blow a hole in something that people are relatively commonly doing and is fairly popular with developers. That forcing the authorization server to know every single possible resource that somebody might use an access token at will, I think, limit the use of OAuth. So I think that the authorization server metadata is pretty well baked, but I think we need more work on the resource server stuff, and I'm hesitant to move forward with something that says the authorization server must know all the resources that a client could possibly use this token at. I think that's probably an overly restrictive way of approaching it.
Okay. So any other views on that topic? Good. Okay. This is the audience restriction.
John Bradley again, sorry, I got a request from Phil. So Brian Campbell and I did do a draft sort of based on the proof of possession stuff, where a client can indicate to the authorization server where it intends to use the access token so that the authorization server can appropriately audience restrict the token that it's issuing and or choose the appropriate format, whether it's opaque or JSON Web Token, or put the appropriate keys in if it's using symmetric proof of possession. So that is, some people really liked it, other people flipped out when we introduced it. So I don't, it's sort of sitting, that draft is sort of sitting on the sidelines. We would be happy to advance it. What was it called, Brian? Resource indicator, I think.
It's Phil again. I just wanted to add, initially I had a bad reaction to it, but in the context of the other issues we're trying to solve, I think we should still keep that idea on the table as part of the solution matrix, along with the whole proof of possession. It just might fill the gap
Eventually
I'm
you'll
worried
warm to
about.
it, Phil. It's a
Yeah,
good,
yeah.
it's a good idea.
So, like, let's not forget that idea.
Thorsten, I would like to point out the new security document covers the threat Phil is concerned about, and it also references different ways to mitigate that, and resource indicators is one of the mechanisms that's referenced.
Brian, do you want to say something? Okay, so I would like to wrap this up. So you've all heard different views on how to proceed. So that I think there are two questions. The first one is whether we should move forward with the authorization server metadata document. And the second one is on which is the authorization server metadata is already a working group item or has been for a while already. So there's no doubt about that. The second question is about the resource server metadata, which is not a working group item. And so the question there is whether we should adopt it as a working group item and work on it as some people had suggested. So two independent questions. So the first one, who is in favor? So raise your hand if you're in favor. Raise if we should continue our work on the authorization server metadata document. 3, 4, 5, 6, 7, 8, 9, 10. Yeah, AS metadata. So I see 10, 2, 4.
What's continue mean?
Say again?
What's continue mean?
And continue means like we try to finish it in the group. Yeah, the choice is either we continue it or we drop the item. They're like what does reconstitute mean? But that's just a document management. I don't want to ask the group about that.
Well.
So the way how I see it is either we finish the work on authorization metadata, and if the group then says we want to also pick up the other item, then we have the both items on the table, and we finalize both of them. Whether they happen to be finished at the same time is a separate story, but.
Well,
Phil,
I think there's a bunch of options. You can keep working on this as a standalone, and then we make another decision about resource server as a standalone. Another decision is to work on them together as a complete solution to deal with the security issue, and then the fourth decision, do nothing. That's why I want to keep working on the metadata problem, but if it's just AS metadata by itself, then I'm less comfortable with saying I want to work on it.
Okay. Okay, so those are the questions. So raise your hand if you want to work on the AES metadata document as a standalone item. 1, 2, 3, 4, 5, 6, 7. 8. Yes. And since they are.
Isn't there another option of not doing the RS metadata?
Not, no, okay, yeah, not doing. And then stop work on metadata to begin with. Okay. Who thinks that we should work on the RS metadata as a standalone document? Raise your hand. 1, 2. Okay. Who thinks that we should not adopt the RS metadata as a working group item? 1, 2, 3. Okay. Why 5? I only saw 3 hands. Raise your hand again if you think we should not work on the RS metadata for now. 1, 2, 3, 4. Now 4. Okay. If I ask again, it's probably 5. Yeah. So if I don't like the result, I just ask again and again. Raise your hand if you think we should have a combined AES RS metadata document as a working group item. 1, 2, 3. Oh my God. This is...
I assume 1, 2, 4. May I raise my hand for 4 as well?
Do you want? It depends what you want. So we
If we don't work on the documents, then the documents are fine with combining.
Okay.
Depends on how he's aggregating.
Okay. And who thinks that we should stop the work on metadata altogether? At least that's clear. Or Tony, did I see your hand or not? You went.
If any of these happen, I vote for the last.
Oh my God. No, you need to decide what you want.
We're not doing a transferable ballot.
Okay.
Yeah, that happened last week.
So, William is a +1 on the line.
Okay. So I'm trying to interpret this. So I think that's a really interesting. So I see lots of people who say that they want to work on the or finish the work on the AES metadata, which is the current working group item. I see a sort of mixed feelings about the RS metadata and the combined version. On one hand, 5 people want the combined version, but 4 don't want to do it RS metadata at all. How does that make any sense? Yeah. Yeah, of course. So, Kathleen, do you have an idea what I should do here? So I think it's clear that.
There might be another useful question you could ask.
Okay.
Is how many people don't think we should do AES standalone if we're
Phil, here,
doing
I
combined?
I think this is reflecting that there's not a lot of consensus on the use case or the problem we're trying to solve. And that might be at the heart of the issue. Some people just saying, I just want to publish metadata and I need a standard form for that. And that's great. And there are other people like myself who are worried about some security implications and are less driven by the metadata. But we understand the problems go together. So,
no, I don't read it that way. Because clearly for 2 different metadata issues, the use cases are different. William.
Yeah, I definitely disagree that they go together. I mean, we have an absolute need for the authorization server metadata like right now, and the RS one, at least for my team, hasn't come up yet. I'm not saying it's invalid, but I don't see why these are mutually exclusive. I think if enough people want the authorization server metadata, let's just get it done. And that doesn't preclude any other work on any other metadata docs. I don't see why it has to be mutually exclusive.
Okay, that's a good point. So let me add 2 other questions. Who has the intention or is already deploying the AES metadata document? So we have 1, 2, 3, 4, and I think William as well.
What's the vote?
The question about.
I see they're not putting up their hands when I know they have.
Yeah. So the question was about either the willingness to deploy or whether you are deploying already the AES metadata.
The question is there, sorry.
What is so unclear about the question? I'm asking a question about the deployment.
Accent, I'm sorry.
No. Oh my God, you.
Tony Nadlin, so we're using it, but it doesn't meet our needs. So that's our concern, is the multi-tenant issue. So,
Mhm.
you know, it's not of use to us at this, you know, it's a basic use for us, but won't handle us in the future. So we're very concerned about this.
Okay, then.
I have one more question. Is anybody using metadata outside of OpenID? Because I think OpenID is the prime one. So you've got one. Okay, thanks.
Okay, so can you?
I think Oracle's the same.
The
Thorsten.
Oracle is the same that you deploy it, or it doesn't meet your needs? Okay.
No. You're lying. You're a constant liar. Yeah, this is Tony. Tony equals to lying. Thorsten, Tony, you're constantly referring to issues Microsoft see with AS metadata and tenants. Can you please explain the issue?
Yeah, how do we
Microphone.
Tony Nadlin. So to answer Torsten, how do we handle the metadata? How do we handle the case that we have multi-tenants? So we have in Azure, right? You can get the metadata but we need to be able to distinguish between each of the tenants, you know, which authorization servers that they're going to be able to use. So right now it's it's done as a single entity, right? It describes, yes, John, it describes how you do, yes, which is a really non-scalable situation with Azure. Use the mic, John.
Thank you for pointing that out, Tony. John Bradley. So at the moment, the model is we support multi-tenants by allowing you to publish each tenant as a separate document so that you can keep the settings separate. Microsoft does have one of the co-authors and has, so if people have concerns about multi-tenancy that haven't been expressed yet, other than Tony at this meeting at the microphone, it's, you know, we can change the document. That's more of a discovery issue than an actual metadata issue. So given that the document that we're talking about doesn't really talk about discovery, it only talks about the metadata, I think we're slightly being sidetracked by that issue. But certainly there's no plot to not support multi-tenant. That's
all right. So Tony, to your point, doesn't Salesforce do exactly the same thing with multi-tenancy for SAML metadata, and it seems to be working okay?
I don't know what they're doing.
I'm pretty sure they do. And you know, you just generate metadata for your tenants, right? It's not out of the realm of possibility to do that.
But we've been through this with our team, with Azure team.
I'm saying other people do this, right? It actually is doable.
Maybe they don't have any tenants.
I think that it's Phil here. It's almost like a metadata for the metadata for the metadata problem. Like, where do you start this process of, you've got a client and it could talk to any one of 1,000 different tenancy endpoints for its resource service. So where does it go to discover? Does it go to Microsoft.com, Azure.com,
But the AS
Oracle.com,
metadata,
and how does it get from there?
but Phil, it's like I'm in this specific question, I was only talking about the AS metadata document. It doesn't describe the discovery itself. So I think there are lots of questions on different aspects, but at the moment I'm just trying to figure out, like, what is the status in terms of deployment of the technology, and then as a second question on where are we with I'm trying to find out the need.
There's a theme here that a bunch of magic is happening, and suddenly the client is magically aware of what discovery endpoint to use, and then once they have that magic solution, then everything they get will be valid. And I think we're saying, step back, solve the magic, because the first problem we always have is, which tenancy are you connecting to? And that usually involves authenticating the user, and you have to have some bootstrap process to get in, just to get to the authorization server metadata. And I think that's where the tenancy problem gets really complex.
Okay, let me have William jump in. William.
Yeah, I'd just like to answer the need question. Like we have a specific need right now where we're going to allow people to bring their own authorization servers, bring their own Oauth servers. And, you know, in light of all the mix-up concerns, we need some way that they can prove who owns the token endpoint. Otherwise, they can bring someone else's authorization endpoint and their own token endpoint and just steal the codes. So this is a very real need that we have, and it's solved by this spec. This is a way that an authorization server can programmatically declare who its token endpoint is, what the correct token endpoint is for that authorization server. It's very useful if you ever have a situation where developers are going to be bringing their own and registering their own Oauth servers.
Thank you. Thorsten.
Thorsten. Phil, from my perspective, AES metadata is rather simple. As a client, you get configured in the URL, or you get provided with an URL, and then the process starts. That's what AES metadata is all about. There's no algorithm for determining the URL. It's just the URL, and you obtain the metadata this a JSON document. That's the way we use the configuration right now, and it's very helpful. So no magic at all, from my perspective. And I would like to support what William said. AES metadata also provides us with an AS identity, something we didn't have before, and it will help us for mix-up and all the other attacks. So please keep that in mind.
So to count the numbers. So when I was previously asking about your AES metadata deployment, could you raise your hand again so I can actually count? 1, 2, 3, 4, 5, 6. AES metadata deployment. 1, 2, 3, 4, 5, 6, 7. 7. Huh? 8. Deployed or planning to? Oh, deployed or planning to? 8. 9. Okay. So there's a document available for the RS metadata, which we had discussed before, and I would like to get an understanding of where things are with that. Are you either doing that already or planning to have RS metadata? Raise your hand. Deploy. 1. Okay. I think Kathleen, correct me if I'm wrong, but my reading of this is that we should go ahead with the metadata. We seem to have discussed an issue on the single multi-tenancy, and that we may need to clarify. Maybe it's a misconception about where the process starts, and the document needs to be clarified. But I see people using this already. I see people who are interested to progress it as a standalone document. For the RS metadata, I feel we need more investigations about the type of problem we are solving there. I think we need to put more work into that document to get the group on board with it. Is that sort of did I hear the feedback correctly?
Kathleen Moriarty. So I think so. Nobody said to stop work on it, but clarification is clearly needed because there's not consensus across the go forward plan.
Yeah, for the RS. Good. Yeah, thanks for the feedback. It was very helpful for me. Okay. Brian, now it's your turn. Whatever you want. Okay.
I don't know.
It's up to you. Of course.
I'm still in the pink.
All right, I'm going to talk about token binding for OAuth 2. There's my intro slide for draft 01. Can you give me the next one?
Yep.
So what are we trying to do here is specify a means of using token binding with OAuth, also OpenID Connect, just as a sidebar, to defeat replay of stolen tokens including codes, for refresh tokens, ID tokens in that case as well as, and access tokens and authorization codes. So token binding is a means to bind a key to a token and defeat the replay of such tokens from other clients or devices. Next, please. So after Berlin, we adopted Mike's draft as a starting point for a working group draft that was unchanged into the initial version, the 00. And there was a small update to bring us the 01 that changed the token binding for access tokens, the establishment method to use the referred token binding versus an explicit parameter, request parameter. It defined a protected resource metadata value, which relates back to the previous discussion. And Mike went through to try to use a more specific term of protected resource versus resource server, I believe. So not a lot of changes there. The first one being the kind of the major one, pretty fundamental difference where previously we were coming in and presenting an explicit parameter saying this is the key we want to use. Now we're sort of deferring to the lower layer of the stack in token binding where the referred token binding idea is being presented via the token binding header mechanism. We'll talk about that a little bit more coming up. Next one, please. So I want to give a quick kind of review of token binding, just to give some context about what it is and what maybe it'll provide for OAuth. What token binding does is uses a public-private key pair generated by the client, not the OAuth client in this context, but any sort of TLS client, could be a browser, could be an OAuth client, but whoever's on the client side of the TLS relationship. And that key pair is used to sign the TLS exported key material, the EKM, which creates a long-lived binding to the key pair on the client that binds it to each individual TLS session. So even though it's bound to the session, it's actually being signed by this key pair that's longer lived. So it creates a very long-term binding to that particular client device instance. It's split up into 3 drafts. Token bind negotiation. Oh, I screwed up that there. Sorry. Negotiation is in the 5th draft. This just defines a TLS extension. So when you're negotiating TLS, the client says, hey, I want to do token binding. The server says, great, let's do it. And then it's established via sending a header in future messages, although that's defined later. The protocol defines the actual message format, so just some binary format to express the token binding keys, the ID, and you can have more than one token binding in each individual message. That's all defined there. Importantly, it defines 2 types: the provided token binding, which is the main one negotiated between client server, and a referred type, which is a referred token binding. So it's a way to express the key used to bind tokens between a client and server to a different server, which allows for cases like OAuth, where you might want to bind to have one entity like the authorization server who's minting the tokens, bind that to a key that the client will use with a different entity like a resource server, a protected resource. And then finally, in token binding HTTPS, it talks about how to actually embed token binding messages in HTTPS. It defines a new header, sec token binding request header, which is what actually sends up the token bound message. So in that, the client signs the EKM with its key pair for that particular server and embeds that in the message, including its public key, base64 URL encodes it and sends it up as a header. Then that basically identifies the key, proves possession of it with a signature, and then the server can bind messages to that key and sort of tie those 2 together. It also defines an include referred token binding ID response header, which in redirects is how a web server can communicate that the referred token binding should be communicated to another server. When it receives a redirect with that header and it makes a request to the target, it includes both its provided token binding ID, the one that's directly established there, as well as the referred between it and the other server, so it can accomplish those federated use cases. So the first thing that's defined in the draft in section 2 is token binding of refresh tokens. This is pretty straightforward. It's just like binding a cookie. So the token binding is established, and all that has to happen is the AS has to bind that key into the refresh token. When it issues a refresh token, it binds it to the provided token binding ID from the client over that channel, And when it's later presented with a refresh token, the authorization server has to check the token binding ID against the provided one that the client presents. So it's just basically including that key either in or referenced to the refresh token. And all this is transparent to the client. It doesn't know the difference. Next one, please. Real quickly, representing token binding in JWTs or JOTs. So we added, there's a new RFC 7800 member for JWT confirmation methods. It's TBH, which is short for token binding hash. I kind of wish it would be TBD, just could be cute, which would be token binding digest, but it's maybe too late for that. TBD would be fun. But anyway, because it's kind of how a lot of this work is. It's to be done later. Its actual value is a SHA-256 hash of the token binding ID. And I don't know, I had an ID, either in an ID token or in any JOT. It's defined in OpenID Connect token bound authentication. There's a URL there, but that's all there really is to it. Here's an example of it. You have the comp claim from 7800, and then the subnumber of that is TBH, and base64 URL encoded hash of the token binding ID, which is effectively the token binding ID is just the public key of that client server relationship with token binding. Okay, next on us. So token binding for access tokens. This is currently defined in section 3 of the working group draft. This binds the access token to the token binding key used by the client in the TLS connection between itself and the protected resource. When issuing an access token, the AS needs to bind that access token to the referred token binding ID presented at the time. So that's the token binding ID of the other server. It's making a connection to the authorization server, presenting it with 2 token binding IDs, one of its relationship there and one of its relationship with the resource server. And the AS binds it to the latter so that the client can use that token and prove possession of that key with that with the resource server. And it does this with the referred token binding ID presented either for tokens. Wow, I got that mixed up. Yeah, I'm sorry. That's totally so switched up. So for tokens from the authorization endpoint, which would be the implicit flow, it does this via the referred token binding sent to that endpoint. And then for the token endpoint, which is really everything else, the code, refresh, and all other grants go through the token endpoint. It picks up the referred token binding off of that. And then when actually presenting the access token, the protected resource validates by comparing the provided token binding ID that it gets over that channel with the token binding ID, probably hash of it, that's embedded in the access token. If they don't match, it rejects it. Next one, please. So using referred token binding IDs, I think conceptually this is definitely the right approach, but there's a few little kind of gotchas related to OAuth that I think we need to at least sort of work through or think about. One is that no redirect occurs between the protected resource and the authorization server. Generally, OAuth flows kind of start out with the authorization server, or even if they don't, and a client goes to a protected resource first and it doesn't have the right token, it's going to get a 401 or a 403. There's no 30x redirect to the server, which is how token binding now is signaling that the referred token binding should be shared with that other party. So there's a little bit of an allowance for this right now in the token binding HTTPS spec. And it basically, but right under that, it says applications must only convey token binding IDs to other servers. That would be to the authorization server. If that server associated with the token binding ID explicitly signals to do so, for example, by returning the long header response in the header field. I think right now, if you read that text fairly literally, which is what we do here, that more or less prohibits the OAuth case because we don't have a method to explicitly signal the release of the referred token binding ID to the authorization server. I'm not sure that was exactly the intent of the text, but that's what's there now. So I believe we need to do something. One is to get that text changed, or we could just interpret it very, very, very liberally and say that it really was meant to allow this, or add some kind of explicit signaling in OAuth itself to sort of work around the case. John.
John Bradley. So Dirk isn't here to defend himself yet.
Dirk is here.
Oh, hidden in the back. So Dirk, you're the I think that my interpretation is that language is probably because that document was largely focused on the HTTP redirect case, but we also have the JavaScript fetch case, which isn't triggered by a redirect, and the various API cases. So I think we probably need to rework that section so that it's not completely dependent on the pretext. So there's a bunch of HTTP messaging stuff that OAuth needs, but the redirect just happens to be in the same document. So I think, are you okay with doing a little bit of refactoring there?
Yes, this is Dirk. I would think that maybe, so just looking at that paragraph, I want to say maybe the edit I would do is, instead of saying applications, I would say web browsers or something like that, and then leave it up to other applications to have different rules.
Well, web browser may also affect the JavaScript case, so we have to.
Yeah, and it explicitly already isn't limited to just that response header there, right? The response header is just an example, but yeah, I think we can fix that.
I sort of think that was the intent there, but
so the principle is that, you know, the thing that's making the request not cause correlation that it's unintended, but in the OAuth case, the client is the thing that gets to decide whether or not it wants the two connections correlated. So it's really the client that needs to make that decision, not the resource server. So the resource server would be, you know, adding signaling for the resource server. The resource server's opinion really doesn't matter in the OAuth case. It's what is the privacy consideration of the client. So we just need to make sure that from a privacy perspective, it's the right thing that's making the decision about whether or not a potential correlation can occur.
I think I agree. So can we work on that text, Dirk, a little bit? I think. Good. So that would be the first option, and I think that's the right way to go. Even with all this, I think there's a possibility that this could prove cumbersome in some situations in client development. One example that comes to mind is a native app using a different code path or set of libraries to interact with the token endpoint versus interact with make API access. I know people sort of cringe at this, but I think it's exceedingly common that this happens. So being able to share the referred token binding across those two different stacks could be rather cumbersome. People have mentioned like clustered web server clients could be difficult to work with in this case, and I'm sure there's others where it maybe not impossible, but certainly hard. I don't know. I don't know if that's reason to do something else, but it's come up previously, and I think it's worth mentioning that sort of strict use of the referred token binding ID is the only mechanism to convey it may prove problematic in some cases, or at least difficult to deal with. And then I wanted to mention that in HTTPS token binding, there is currently now a should for using the ETLD +1 scoping requirement around the referred token binding, or the token binding in general, which is only a should, but there's at least a potential for sort of an impedance mismatch here, where currently we have OAuth tokens that are issued and sometimes used for a wide variety of different servers. If you follow this to the letter, you would have to get a new access token sort of for each resource server you want to interact with if they are in different top-level domains, or different effective top-level domains +1, so it's sort of the next layer down. Or the client could potentially just sort of move around this should and continue to use the same key for all of its target servers, which I think in this case actually is,
okay.
well, I mean, it's going to use the same token anyway, so there's no additional correlatable information. All it does is mean that token can't be replayed by those servers against other servers. So all it really does is vastly improve the security and doesn't take away any additional privacy from what's already happening. So that's probably how I would do it, but it's sort of, it's a little bit of uncharted territory right now.
May I ask a question?
Yes, sir.
Torsten, so what you're meaning is even if the client uses the same key pair for all those resource servers, the resource server can't replay because it uses different TLS connections?
Yes.
That's what you're saying?
Yes.
They only get the public key, so the private key is still controlled by the client.
Mm-hmm.
Well, it's from a security point of view, it's fine because that's the whole purpose of the mechanism. But I'm I'm not quite sure I understand sort of the privacy idea that you have in mind, because just because there's it's a subdomain doesn't actually even mean anything, right?
Well, if it's a subdomain, it'll work, because that's sort of how it works with token binding. Subdomains will get the same key. But what I mean by the privacy is if there are already deployments where a client is using the same access token with example.com and IETF.org,
so
it's already correlatable because it's the same access token, it's the same identity, it's the same authorization server.
So for
if all you do is,
are you saying, for example, if it's like .org would be the domain you would share with all the subdomains the same token? If that's not correlatable, then I don't know what.
No, it's absolutely correlatable.
Yeah.
What I'm saying is it's already correlatable. So
That was. May I support you? So Thorsten,
Yes.
I think that's happening, right? That's happening out there. Our deployments with different resource servers and clients use the same access tokens, but the security domain or the AES can do differently. So for example, we use audience restricted access tokens and force the clients to use different access tokens for different resource servers, right? So we don't have that privacy issues, but I'm not quite sure how token binding is going to work in our deployment. Because in the end, the client needs to somehow determine when to get an access token for a different resource server, and I don't know what the relationship is between this key pair and the different access tokens. So one thing you pointed out, that the client could use the same key pair for all the resource servers, which would mean, from my perspective, that the client must be able to manage the key pair explicitly. I don't know whether this is really the intention of this specification, and if it's possible. I mean, you need the API for that, right?
yes,
So is this something theoretically, or is this possible?
I somewhere in the middle right now. These things are being developed, and the APIs are sort of being worked on. And it's not entirely clear how much of what API will be exposed to whom and who will end up managing the keys.
So John Bradley, so some of that may be platform specific, but in general, when you're making either a JavaScript fetch call or an API call to include the referred header, you're probably going to have to say what URI that referred token binding actually is from. So a client could say, I'm going to make up one referred destination I'm going to use for everything and always include that. Or it could, if it wanted to divide them up for some reason, make up individual ones and get different access tokens. But it's going to have to, from a privacy point of view, you want to probably have different keys for different access tokens. So if you have 2 different access tokens, then you should probably have 2 different keys for them. At the moment, the implication is that even if you only really need 2 access tokens, you may need to get 5 if each of those resource servers are in a different domain. So what we're just trying to raise is we might want to think about what that relationship is, so that we can so the client can match the unique keys with the unique access tokens, as opposed to necessarily being forced to get more access tokens than it really needs.
Ben Kadek. So yeah, you're absolutely right that if the access token is already being shared across multiple things, there's no need to have separate token binding keys. I think the token binding specs are pretty enthusiastic or insistent that the clients have different token binding keys for every different server, because they're super paranoid that there could be different servers that try and collude and track the client as it visits different servers. But since the access token is already something they could use for that, there's not really a need for the separate key pairs. On the other hand, these people that are really insistent about client privacy might say you shouldn't do that, and you should get different access tokens for the different domains.
So
for the minutes, can you repeat your first sentence? You read that if you already...
If you're already using the same access token for different sites, you don't need different token binding keys.
So just a couple of reactions. One is I think you're right about the token binding specs, and I think they're written largely with a web browser used web browser client in mind, in which case the possibility of having sort of a shared super token that's done for everything and tracking is very real and very concerning. which is I think why they're so skewed towards making sure that doesn't happen. Right. And I agree with it, but they're written with that in mind, and I think not necessarily considering cases like OAuth as broadly as some of the other cases.
Right, I agree.
And even if in cases where if you had a privacy preserving client or deployment where you were really concerned about, there's nothing that prevents a distinct access token being acquired for each different resource and using a different key with that. So it's just, I'm not sure where we're driving to, but just discussing some of the issues.
Right. Well, I think Hannes was expressing some confusion, so maybe we've clarified that for you.
Yeah, and I see, like you described, I see these privacy challenges that will come up. And if the mechanism provides a way to allow the client to request different keys and different access token for different resources, I would obviously help. If everything is sort of under the control of the server-side infrastructure, then I think we may potentially lose some of the privacy properties of the OAuth protocol. Because I could imagine that some deployments are inclined to say, if I have to spend all the effort for the crypto, then I will make, then the mechanism allows you to provide better security, then I will just go ahead and use only one access token for all the resources, while I have previously been using issuing separate tokens. I could guess, but maybe.
Justin Richer. So I think largely my skepticism of token binding and used in OAuth is that token binding is a brilliant solution for browser cookies, and OAuth tokens are not browser cookies. So browser cookies are meant to be bound by domains. That's kind of where this ETLD +1 thing comes from. That makes absolutely perfect sense to have that kind of thing. I mean, browser cookies have the domain and path even, and that might want to be something HTTP spec wants to add in. But OAuth tokens don't work like that. I think we in this group know that they don't work like that. And furthermore, clients, and specifically client developers, tend not to think in terms of domains that they're calling and stuff like that. They tend to think in terms of the functionality which is defined by the API. So these client developers will effectively say, give me the list of URLs and things that I'm going to need to call to make this API work. I don't care where they are. Going back to the earlier discussion of how we do resource server discovery and how that's bound to these things. In most cases, that is done statically and out of band. We are going to a world where that is more dynamic, and that's where I think more the RS discovery metadata question comes, and that's a really hard problem to crack. But in however you get the information, the client ultimately is not really going to be thinking in terms of, oh, I'm calling this domain versus that domain. It's going to be thinking in terms of, I'm calling this API, and this is the access token that I need for this API, no matter where it's hosted. And for a very real world example of that, I want to point out Google's OAuth and OpenID Connect implementation, which is split across accounts.google.com and www.googleapis.com. So that's a case where the different endpoints are all over the place. Additionally,
they're still actually in the same ETLD +1, but
it's googleapis.com, not google.com.
Oh, it's
yeah. So it is a different ETLD. Furthermore, if you look at the it takes something like the authorization code flow in OAuth, where everything's all split apart, right? You've got up to 5 different TLS connections that you've got to deal with in the normal flow. You've got the browser to the AS, potentially the browser to the client if you're considering a non-native client, client to the AS, client to the RS, and potentially RS to the AS for token verification. The problem here is that the token is sort of requested and authorized. The whole process starts off on one of those channels. The token is issued on another of those channels. It's used on a third channel, and it's validated potentially on a fourth channel. This is a very, very different world from the space that token binding is intending to solve. And that's what makes me worry that we are working really hard to cram a square peg into a round hole here. I honestly do not believe that this is a good fit specifically for access tokens. Now, ID tokens, when passed in the implicit flow, that's kind of browser to AS single channel, kind of works there. Refresh tokens issued on the token endpoint between the client and AS, sure, like you said in your previous slide, that's kind of transparent. That just couldn't kind of happen, right? But kind of the bread and butter of OAuth is this access token, and it's the fact that you are connecting these different components in different ways that's what makes OAuth what it is. And I think that puts it into a firmly different category than what was intended to be used with TLS token binding. Additionally, what happens when I go start talking to multiple resource servers? Back to the point of the client just talking to an API. I'm really not going to be caring as a client developer where those things are hosted. Does that mean that I now have to start caring? So I think these are all open questions.
I think they're valid questions. Ideally, the client developer is not going to have to know about these things, but there's work that needs to be done to suss out kind of where the APIs for these various components live. And if you use the same key, you don't need to worry about it, and it just works. But apparently, there's some deployment considerations, at least, that will not want to do that. I don't know. I think you make some valid points. I'm not sure where to go with it. I don't think it's as dire as you make it out to be, but there's definitely some challenges that need to be addressed, and they largely come up around the use of an access token,
right?
Or more the acquisition of an access token followed by the use of it.
Right, exactly. It's the fact that it's a multi-stage process. And one last thought is that what problem are we ultimately trying to solve? Are we trying to solve audience limitation, or are we trying to solve presentation limitation?
Yes.
Yes. Okay.
I think both. I mean,
because those are two different things. I mean, when you're talking about a two-party system, they're the same thing, more or less. But this is not a two-party system.
Tony Nedlin. So I'm concerned about the browser situation. You know, I would hope that your last statement doesn't particularly hold true for browsers.
no,
right?
it doesn't. Don't
Okay.
worry. That's
I just-
unrelated. Or we'll talk
No,
about
it is
separately.
related, but I just want to make sure that you're not proposing this for when I'm in a browser.
No, I'm not.
Let us.
Well, John, you want to clarify that?
Broadening it up is not proposed for the browser situation.
So let me clarify that slightly. Certainly not for the browser redirect. I think that we still have some unknown questions about JavaScript in the browser using fetch, where there isn't a redirect, and the JavaScript may need to be able to specify what the referred token binding is. So we'll have to think about that, and the ETLD +1 may or may not be appropriate for that. I don't know that we have a conclusion for that at the moment, but JavaScript in the browser is still of a bit of an unknown.
Let's have William jump in really quick.
Just to be clear, though, I wasn't even proposing a change in this language or anything like that. Just noting that it has some implications on how this is done. But even with the should, OAuth has some latitude. But certainly not proposing a change in that regard to token binding, particularly with respect to the general browser cases.
So, William.
Hi. Yeah, I agree with Justin that I think access tokens are a bit tricky to solve, particularly if you have multiple resource servers. Our situation is actually probably fairly simple because we do, I think, only use one resource server TLD. Though you're correct that there are a couple of different TLDs used in the overflow. I would say one of the really quick wins we can get with token binding is actually on the refresh token, because that's always between only two parties. And there's significant value in I think binding that refresh token. And I think in general, I like the idea of token binding. It's kind of just securing the auth tokens using the TLS EKM. I guess like there could be another way to do that doesn't use the token binding, but I think the token binding probably gives us more than it adds in complexity. That would be my take.
There are certainly other options that we've talked about a little bit, but not in a lot of detail, like doing it more at the OAuth layer, maybe signing the AKM indirectly and not relying solely on the token binding layer. But it seemed like trying to leverage what was there in token binding made the most sense. But it's open, I suppose.
The blue sheet, has everyone signed the blue sheet? No? Okay, where's the blue sheet? You haven't gotten the blue sheet at all?
It wasn't the back.
I don't think anybody.
No, you passed it around. No, there were, no.
This one's blank, so why don't we start it here?
Okay. Okay.
Andrei Popov, Microsoft. So in token binding, there are different levels of specification. The protocol specification only says that the scoping rules for the token binding keys are the same as the scoping rules for the tokens. So basically, we're saying that, whatever way you scope your tokens, don't scope the keys any broader than that, right? That's the intent of that. Then in the HTTPS token binding specification, we'll talk about ETLD because that's what's appropriate to that specification. In your specification, if your token scoping rules are different, you can adequately scope your token binding keys as well. So you just need to discuss that in your specification, basically.
It's a little fuzzy though, because it is HTTPS, but the HTTPS specification is largely written towards a browser use case, and it makes
my point is that your specification can live at the same level as the HTTPS specification if you want it to be there. If you want to layer it on top of HTTPS, then you have some limits. Otherwise, you can just put it in parallel.
So the actual token binding header and everything is defined in the HTTPS. We don't want to have to repeat all of that in a different spec. So
that seems to be an editorial question, though. Like, how do you could say you could refer to this other spec, but define a different scoping if you want to. Like
right.
Nothing stops you from doing that.
Right, but I suspect that it may be easier for people who are building things on top of HTTPS, but not using web redirects to be able to refer to at least part of the HTTPS spec, which is why Dirk is looking nervous about the refactoring that we're going to. Okay. But I think that things building on that spec is going to make more sense than trying to repeat large parts of that spec in OAuth and other places.
Yeah. Okay. And I think it's a very small change to a little bit of wording to allow it.
Torsten, I would like to start with some thoughts about what Justin said. First of all, I think refresh tokens can also get tricky when it comes to token binding, if it comes to clustered environments. Because then you start to share the refresh token among different cluster items, and I would assume, use different keys. Except you share the private key among the cluster nodes. So that's one thing.
Yeah, but the keys, the keys.
I just wanted to point out, not only access tokens are going to be tricky with token binding, refresh tokens can be tricky as well. That's what I want to say.
So on the server side, it isn't managing the private key. So assuming that you are using reverse proxy or something in front of your cluster, it shouldn't be a problem on the server side.
Because you assume we use a reverse proxy.
Yeah.
This is one of a potential solution to that problem, but we don't use a reverse proxy in all circumstances. So I just wanted to point out it could be tricky. If you just document the pattern to solve that, I'm fine with that. I just wanted to give my thoughts on that. You don't have to solve it now.
So assuming that the cluster has the same domain name, I think that's a tractable problem. The bigger problem is the client being a cluster. And I think
that's what I said, the client being a cluster.
Okay.
Okay. Second point, I think developers have to start to take into consideration which access tokens to use on which resource servers. I mean, right now it's quite rather simple. We have static setups, and the access token is used all over the place for all the resource servers, which let the privacy people freak out, and I understand that. So there needs to be a kind of a complementation between the resource servers. So I think we have anyway to talk about how a client could distinguish which access tokens to use at what resource server and how to ask for that particular access token for that particular resource server. OAuth doesn't really fulfill that right now. I mean, you have the resource indicators, we use scopes that way. So there is some work to do, and it's not tightly bound to token binding. There's a general problem of how to really determine which access token is needed for what kind of resource server. So we have to work on that. But what I sign up to ask is, are there any deployment experiences, any development or implementation experiences with what you're proposing? That's my key question. So are there any implementation experiences with this stuff?
I'm not aware of any at this point. I'm working on it, but
Okay.
it's very early.
Yeah, because that's really needed. This sounds so difficult to me. We really need implementation experiences. Thanks.
Mike Jones, Microsoft internally has deployed something with not exactly the same syntax, but similar semantics.
Yeah, syntax is the sugar on top, right?
So I know of some people who are planning on doing token binding for refresh tokens shortly, but I can't name them.
Around the client side, native clients.
Dick Hart. In the spec, is it clear? So for us, we're much
Probably
more
not.
interested in binding on the refresh token because many of our implementations, the access token is very short-lived, and so the security risk on that is low compared to exfiltration of the refresh token. So I want to make sure that we enable the refresh token to be bound, but not necessarily having to force the access token, because there's a lot more complications in binding the access token. So you get an awful lot of the security benefits in just binding the refresh token.
Was that a question?
Is there anything that requires access token, or is it clear in the spec that you can just do the refresh?
It's not explicitly required. It may or may not be clear.
Okay.
Depending on how you read it.
Okay. Maybe.
But the intent is to allow an a la carte selection of different binding.
Okay.
And there's nothing that stops somebody from doing refresh tokens now because it doesn't actually need to be interoperable. So people are moving forward with doing refresh tokens now before the spec is done.
William? What the heck? Okay.
Yeah, just to echo what Dick was saying, we have pretty similar requirements. Definitely see a lot of value in protecting the refresh token, and that's what we're going to try and roll out first. It's also the easiest to prove. As John said, everything's kind of behind the scenes, so we're hoping to get a native example of that up and running this year too.
Dick?
What's got Dirk Palfins. Question about the second to last bullet point on there. If I understood you correctly, between Berlin and the may still prove cumbersome in some situations, please. Between Berlin and now, you guys changed the proposal to remove the explicit mentioning of the key and always refer to the referred token binding. I wonder whether because of that bullet there, whether we don't need both. Sometimes you are able to refer to the referred token binding. Sometimes you have to mention the key explicitly.
So we changed it from explicit to referred in the places where it's possible to do referred, but there's still some cases where we do need explicit.
You can still do the explicit. Okay.
But those are around the code and they're not written.
Right.
Okay.
So around because the native app and the browser may not actually have that. So in the cases where you pointed out in your document, we still intend to have, essentially there's the provided token binding, there's the referred token binding, and then there's the explicit binding, which covers the third leg of the verification in certain circumstances.
All right. Thank you.
But there are not currently ways to sort of do both over the same.
I see.
If that makes sense, like.
Right.
Where referred is possible, use referred otherwise.
Sometimes you might need both. Like, I'm trying to remember when I wrote this thing. I think sometimes you needed to bind like an authorization code to like two things or like two. I forget.
I reread that. I'm not entirely sure that the double binding is necessary.
Okay.
That's not, but I could be wrong. That's
All right.
a coming slide if we ever get there.
Oh, there's more slides. Okay.
Yeah, but we tried for each of the possible legs to only have one way of doing it.
All right.
So you can't decide on the fly whether you're going to send the referred token binding as a referred token binding or an explicit parameter.
Right. Oh, now I remember. Like, yeah, an authorization code, right? You send it from the browser.
I recommend that you read your document.
To the
It's good.
To the server, and from there to the
Yes.
How do you solve that if you only bind it to one?
No, you can provide the referred token binding plus an explicit token binding for the other hop, which isn't direct.
Oh, you can.
Yes.
Okay.
Yeah. So you can provide two different token bindings, but they're for different legs.
Yeah.
One is referred and one is explicit.
Yeah. Okay. Cool.
Except the document doesn't say that right now.
Yeah.
And
That's the next round.
It
of
may
that.
not, but yeah, it's possible.
The authors are of one mind on it.
Why don't we do the next slide?
Already up there.
Hey, thanks. Hey, look, token binding for authorization codes. So this is work that's outstanding that needs to be out of the draft. I haven't gotten to it yet. There's basically two flavors here. One is binding the authorization code to the token binding ID between the client and the token endpoint. And this is I'll talk about it in a minute. The other one is binding the token binding ID to the channel that the browser uses to deliver the code to a web server client. And this actually, it's worth noting, defeats sort of the paste side of the cut and paste replay attack. And then here is where, in Dirk's document that he sent around Berlin, there's a sort of I don't know what to call it, a hybrid of these two that binds an access token to both of these channels for the web server. So it's bound to the channel between the the browser and the web server client, and between the web server client and the authorization endpoint. I'm sorry, the token endpoint. And I'm sort of asking again whether that's necessary. Even in your document, you mentioned it explicitly, but you wavered a little bit on the value of doing token binding over what you called the back channel, sort of the data center to data center. Being able to do both does complicate things a lot. And I think there's other ways to mitigate that channel, like a TLS client certificate authentication for the client, or a lot of other things that don't involve the parameters bouncing around all over. So I'm not sure, but I'm saying maybe it's not necessarily. There's other ways to do it, and it maybe simplifies the rest of the protocol interaction. Next slide, please. So this is not in the document, but this is kind of a rough straw man for how I'd like to see this work. I've gone back and forth as to whether Pixie was the right approach for this or not. But given that it's already there, it offers a few different parameters that help you sort of with crypto agility and so forth. This is a straw man about how I think this might work. So the first one is to bind the token binding ID of the native app client that it uses to resolve the code at the token endpoint. It would use Pixie with a code challenge that's the base64 URL encoded SHA-256 hash of the provided token binding ID that the client will use with the AS token endpoint, and just an arbitrary token binding, or excuse me, code challenge method identifier here that's basically saying this is token binding SHA-256. And then on resolution of the code verifier is the static value provided, which is just to fulfill the requirement that there be something in that parameter from the Pixie spec. And it's also sort of referencing the fact that you use the value of the provided token binding ID in this case to actually do the check. So the initial code challenge, the client knows what it's going to use on that channel. Base64 URL encodes a hash of it and sends it as the challenge parameter. And then when it picks up, when it resolves the code, it provides its provided token binding ID, and the authorization server is able to correlate those two and validate it. The other case is to bind the token, I wrote this wrong, I apologize, bind the token binding ID that the browser will use to deliver the code to a web server client. So this is a case where it's a web server client interacting with the authorization server through the user's browser. In this case, the code challenge would just be referred. That's again, it's a static value to fulfill the requirement that there's something for the parameter, but also sort of a hint to say that what's actually going to be used here is the value of the referred token binding ID that's sent in the token binding header. The code challenge method is just another static value identifying this as the flow. And then on the verification, what happens is the web server client takes the provided token binding ID that it receives from the browser, pulls that off, base64 URL encodes it, and sends it to the authorization endpoint as the code verifier, where the authorization server then verifies the binding between the two. And that effectively binds the code to the channel between the client and, between the browser and the client, but allows the authorization server to validate it based on information that the web server client's providing. These are, the first one is more or less what was in the token binding PXE that was just an initial draft I wrote for the last meeting. The second one is blatantly stolen from Dirk's ideas about how to bind when using a browser. And what's omitted from here is something that Dirk had to do the two together. And again, that's where I'm coming back to. I don't think those are actually necessary. And while it was a really clever idea, it used a lot of constructs that don't actually exist, like stacking together the methods of the code challenge method, sort of like they were scopes or response types, which isn't actually defined that way. So we'd have to do a lot more work to make that work. Whereas I think this doesn't maybe look like it, relatively simple. There's one or two flows here. You use the one that's appropriate for the type of client that you are, and it covers you in that protection. And if you need additional stuff on the back channel between data centers, you do that via a stronger form of client authentication. All right. Oh, damn it.
So these are different methods.
Yeah. Sorry, these are different methods of binding the authorization code to different channels that are relevant based on the type of client you are. The first one would be mostly relevant for native app type cases, where the native app is calling directly to the authorization server to resolve the code, and you bind over that channel. The second one is more for any client generally, but one that'll be using a web server client that'll be interacting with a browser, and you bind between the browser and the web server client so that the authorization code can't be presented over a different channel. So if the code leaked for some reason or whatever, and you tried to paste it into your own authorization and play that again, it would be detected through this mechanism and defeated. So there are two distinct methods using PXE to do token binding on the authorization code that are appropriate for different kind of clients and deployments.
Torsten, I've got one question to the second approach. It verifies the binding between, as you said, of the code between the user agent and the web server client.
Yes.
I would have assumed that the client is implementing this verification. Basically. So what's the advantage of delegating that to the authorization server? And that's what's happening with your proposal.
I'm not exactly sure what the advantage of. The advantage from my perspective was that's how Dirk did it. And also that it fits neatly, although this is a little bit different, it fits neatly into the model that's already defined by PXE. So it just sort of layers on existing parameters and sort of a well-known pattern to do it. You could do it either place, but this seemed to fit in cleaner.
The question from my perspective as well, this is easier to implement for a client.
So the problem is, John, the problem is that there is in OAuth, there is no signed response from the authorization server to say what that should be. So in the OpenID Connect draft, we can put it in the ID token, but in order to get around the lack of a signed response, you have to sort of pass the key in the back channel. So there is no. So the security properties of this are different because this has two web legs, and that only has one. So this is missing.
I would like to focus on the second one because I think this is much more important than the first one. So I remember the discussions we had in Berlin. If we would have a structured code or something like that, and you could bind the code value to another value, then you could do it in the front channel in the client alone, but it's not possible if you stick within the boundaries of the protocol.
Right. So this avoids having to add a signed response.
Okay. But we potentially decide to add a signed response. So based on the security threat analysis, okay, I understand. So this is the way to implement that without extending the protocol?
Right. So this allows passing the token binding ID
of the back channel.
No, of the front channel.
Of the front channel.
This is about user agent to client. Yeah.
There's a possibility of adding another parameter in here, which VirCAD, which also allows the missing link to be validated. The question is,
Yeah. Okay. That sounds reasonable. Thank you.
Just one other thing is that generally this puts the responsibility for doing the checking on the authorization server, which I think many would argue is it's better to put the complexity there versus in the client.
Dirk Bachens, just a comment. I agree that the back channel, I think we have other options to protect against man-in-the-middle attacks. So if it's easier to worry about the front channel only, and I think I'm using the words wrong, like the things that are on the slide right now only, I'm all for that. Like I think this is good, and we don't need the extra complexity of that was in that doc that
The
I
double
wrote.
bind.
Yeah.
Yeah. Okay, good. I was hoping you'd say that. Next slide. Okay. There's also some metadata about token binding for the client. There's basically Boolean values. The client can say whether it can do access tokens or refresh tokens. Not entirely sure what refresh token means in that context. The authorization server, the same things. And then there's a protected resource metadata piece that says whether the resource can do token binding, although that's sort of in question whether that'll proceed, so that may have some implications. On top of the metadata, there's the next slide, please. Sorry, that sounded terrible. So maybe it's obvious, maybe it's not, but it says this, that token binding won't bind, it won't work end to end if not all the participants support it. If somebody can't negotiate it, it's not gonna work. If you don't show up with the referred, you won't be able to bind anything and there won't be the token binding there. And the draft says this, I generally agree that it's a context-dependent decision around the deployment, whether or not to allow the interactions to proceed. If you're trying to do token binding and one of the participants doesn't do it, it's sort of up to the deployment to decide whether you let that go or you stop it. I think at least initially, as this stuff sort of rolls out incrementally, it makes a lot of sense to allow these things to go on. It's sort of a phased rollout that lets you sort of upgrade slowly and in time and let different components come up to speed. And there's a recommendation in there that the general case allows it. Then there's some talk about detecting the possibility of a downgrade attack. And it basically says that if all participants do support it, but one doesn't use it, this is likely evidence of a downgrade attack and the authorization should be aborted with an error. It made sense the first time I read it. I was thinking about it a little bit more. It's much more subtle than that. And one of the main issues is there might be a mismatch in supported key parameters, key parameter types that would lead to the same situation. So it's not just about whether a participant supports token binding or not, but whether all the participants or the right pairs of participants between them support the same key parameter types. Andre, I have a really hard time with that nomenclature. It's probably too late to change it, but it's confusing me. Key parameters, what a key parameters really are is the more or less the type of key pair that you're using to do the signing. And there's two different RSA types and ECDSA. So if the client only supports ECDSA and one of the servers supports only RSA, then that, even if they both support token binding, but they won't be able to negotiate a common set of key parameters and token binding won't work there. So the Booleans previously maybe aren't sufficiently granular to express the possibility of what could happen. And so it's sort of a question then whether we need to expand those metadata values to somehow indicate which key parameter types are supported by different entities. There's also a problem potentially with a metadata for a client where the client metadata is actually about a class of client applications, like a native app on iOS commonly uses the same client ID with the same client metadata. And it's likely then dependent on the other underlying operating system or what version of that is, whether it can really do token binding or not. It may not be specific to the actual client instance, but to other factors of its deployment. So it might not adequately express yes or no. It might be dependent on the deployment environment of a specific client, but we only have metadata about that specific client. And again, I'm not sure what's going to happen with resource metadata, but the AS oftentimes doesn't actually know the resource in question. So it would be difficult to make this determination and even more difficult to sort of make it appropriately. I'm not sure what to do with it. I think either the parameters need to be expanded to sufficiently convey all the information that needs to be known, which would be difficult, or possibly the draft need to back off a little bit on the wording about detecting the situation and aborting it, because I think it might lead to sort of erroneous aborted authorizations. If that made any sense. Barely makes sense to me, but next slide. So no next steps anywhere is somehow, and I think we got this maybe covered a little bit later today, resolve the conflict in the wording with HTTPS token binding. So we can just make sure that the sort of implicit signaling involved in OAuth clients is allowed there and isn't read as though it's not allowed. Need to add the binding for the authorization codes. What I put up there is a sort of a rough straw man for what I want to add in the coming weeks or so, maybe take a little bit longer than that, but take a look at these slides and give some feedback if there's specific feedback on that method, but that's sort of the rough idea that I'm going to go forward with. And then we need to flesh out or back off of the metadata and the downgrade detection functionality or advice. There's probably more to do too, but that's what I know about at this point.
So I think Thorsten brought up this issue with implementation experience, and it seems that would definitely be needed. I think a good opportunity would be the hackathon at the next IETF meeting, so we could sit together and put some of that stuff together. I talked to William, and he said that some of the underlying features that we would have to rely on are probably available at that time frame already, so we could make use of them and then sort of add the OAuth related pieces on top of it to gain some hands-on experience. You don't, yeah. Too boring, Thorsten?
Yeah. Yes. I do think experience is definitely needed.
I think
at this
it
point.
would be fun.
Yeah, and I didn't include it in the goals here, but Mike referenced this as an explicit goal in the last meeting, and one of those to have this document out there is to get specific implementation experience around it and get feedback from it. And I think that's still the case. This stuff's early, and so actually working against it, understanding what some of the issues are and working through those is part of the goal here.
Cool. Any additional thoughts? There's a lot of stuff.
Thank you.
Good. But don't run away.
Already?
Mm-hmm. So we still have, we won't get through all of it, but should we talk about the token exchange?
Sure, that'll be fast, I hope. All right, OAuth 2 token exchange, it's been around for a while. We're on 06. We're in Seoul. Good. So I'm going to do a current status. Draft 6 was published about a month or so ago, or a little more than that, with some relatively minor changes. I removed some wording that some people found objectionable. I thought it was kind of funny, but it is what it is, and it's gone. So the joke is gone, and a little bit of the sort of the fun is gone. You killed the fun, and some of the words that were maybe more
marketing.
More opinion-based than strictly factual are also removed. Heavyweight and lightweight are taken out of there. So it reads as just a little bit more factual, and hopefully this makes it more accessible. That was the goal. Added some just wording clarifications around the describing the various token types. Nothing's changed, just tried to be a little bit more clear about it. Remove the want composite request parameter, as it was ultimately the authorization server's decision as to what kind of tokens it issues and whether those are composite with 2 identities or not. It's completely up to that. So giving the client a mechanism to sort of ask for something, only complicated things with no actual teeth behind it. So I pulled it out. And then I added a short mention of proof of possession style tokens, basically saying it's deployment policy, whether this happens or not, and remove the associated open issues. So whatever we end up doing with token binding or POP architecture or anything will either be applied directly here sort of by inheritance because it works with all grants, or by explicit mention in those documents. But right now, this spec is basically the goal here is not to encumber it with references to forward-going work and let it proceed. And that's it. So next. Are we ready for working group last call? I think so. Someone on the list recently said yes, but that's the question.
Thorsten, I I have to admit I didn't closely follow the work on this draft, but I have to
I
say
appreciate your support.
wait. I think the current version is really lightweight.
Can I put that word?
I really like that. Some thought about it. I really like this parameters resource and audience. You know what's coming? What I'm missing is this description of the relationship between audience, resource, and scope. Right? So this is more a conceptual problem, I think, and it's a problem that has OAuth in general. So although I really appreciate that that you are offering the option for a client to ask for access tokens for specific resources, as I said, the relationship to scopes is undefined yet, as far as I understand, and I think it needs some clarification.
I know, yeah, we've had it again and again. I don't think it's appropriate or in scope for this draft to try to solve that problem, although it does introduce the resource. I mean, one of the goals was to pull that out and make it a standardized sort of common parameter. There's been some lack of sufficient interest in doing that. I think it's still necessary for these cases because this is kind of how general token exchange works. When you're asking for token, you
better need to tell what token you want.
You got to say where you're going to use it. So the parameter is strictly necessary for this. And I guess I don't know how to do what you're asking, and certainly not for the larger OAuth, let alone in the context of this document. And at the same time, I think it's still very useful for what it's intended. I'd be open to adding some text, but I don't know what it is.
Yeah, I understand. So from my perspective, I mean, we have an implementation of a similar flow, and we just use scopes in that context. So from my perspective, scopes would be sufficient to exchange tokens.
And you can still do that.
Potentially, because we use the scope to also encode the resource server.
Yes.
I think at least what the spec could say is either those three parameters are mutually exclusive, or the assumption is that if the client asks for a resource server or for a resource and also asks for a scope, that both are combined. Or that the assumption is that the access token is good for the resource and all the scopes that the client asked for, because that's not necessarily the case.
Okay.
So I think that would be okay.
All right. Will you help me with the wording? Will you help me with trying to find that wording?
Tony Nadlin. So we've been going through this with the developers at Microsoft. And so far, we haven't been able to map it correctly into our existing use cases. So I've asked them to document the exact use cases that they're looking at, and so that I can post them to the list. So currently, you know, forcing it into last call may be a little bit too early.
But Tony, the document has been around for quite a while.
I agree, but when we went down to implement it, we're running into problems. So you asked for implementations, that's what we're trying to do, and our developers are having problems.
So when do you think that developers will be able to provide that feedback?
I asked it for them this week.
So do you ask them
to provide it to me
by this
Yes.
week? Okay, that's good. So trying to find out like this issue of the resource indication.
So, John Bradley, that's sort of my question is, is there some sort of consensus that resource may actually be more generally useful than just for this? Should we attempt to reconstitute the standalone resource spec so that
that's what I was
so that it
trying
can
to
be
get
pulled
to.
out? That was
Yeah.
a brilliant idea. I commend you for it.
I like that idea as well. Let's hear what William has to say.
I actually agree with Tony. I think perhaps it's a tiny bit early to do working group last call. I'm very, very supportive of the work, but I'd like us to get a few implementations done, which we can hopefully do early next year.
I'm all for that. I just ask that feedback be meaningful and solution oriented. Some of the feedback we've had along those lines so far is just, it's bad. I don't like it. And there's the.
I mean, yeah, I like it
that.
for what it's worth, but I'd just like to see us prove it out. Yeah, I understand, but
that was a general.
I think it's valuable for us to prove it out with some implementations that it sounds like a lot of people are working on. So it's just that those, we might find some things that need to change the spec. That's all.
So this is Justin as one of the authors of a long distant predecessor of this work and implementer of our dusty old expired draft version of it. We will eventually join the implementation brigade when we get a chance to do that. And I agree with William's comment that I think more implementation experience would be good for this, especially because it's not that, that's a theoretical thing. We're waiting for developers to show up. It sounds like people are ready to start poking at this thing in kind of pre-draft state, which I think is good. To the reason I got up though, there was a bit of discussion about resource versus audience versus scope, and I do think that that's something that we have to sort out in terms of kind of the larger Oauth world, and I think it is applicable beyond just token exchange. And I think one of the problems is that classically systems that split these things out get them mixed up in practice. Look at, SAML has various fields like this, and nobody seems to remember what each is supposed to be used for semantically. And I would really hate for us to run into that same mire by using the same terminology and kind of the same assumptions and everything like that going into it. That said, I think there's a pretty strong call towards greater multidimensionality and expressivity than plain scopes gave us. Now, plain scopes have the benefit of being incredibly simple. One bucket of strings, and each string means what you want, and it combines however your API decides it. There's a lot of power in that simplicity. The problem is there's a lot of power in that simplicity, and it's led to some really confusing use of scopes. Like I think it's AOL has the online access scope, which means your access token is only good if we've seen you on one of our properties front end pages within a session timeout period, or something really weird and esoteric like that. It's not really what is this token good for, it's under what circumstances might this token even be accepted. So there's all sorts of things that people are expressing with this. I do think we need more than scope. I'm not convinced resource and audience are the right cut for it, but I don't have a better answer right now. But I do think that's something we need at a wider scale.
I don't disagree. And they may or may not be the right thing at a wider scale. For this use case, there's fairly specific to allowing the client to indicate where it needs a token for, and that's something that's pretty fundamental in this kind of case. Having built WS Trust Token Exchange previously, that's where we key everything off of. The client says, I need a token for over here. Server looks up over here, applies policy, mints the token. So they're necessary here. I don't know if we want to hold up everything and rehash old drafts to try to pull out commonality there. I'm a little hesitant to do that.
Thorsten, I have to say that I think this use case is very relevant for every client. Every client should be able to indicate where it wants to use the access token. So it's not only for token exchange.
I guess I agree.
You forced me into
I know,
that reaction.
And so I tried to pull that out and put it forward as a draft that would allow for that in the general case. And
I don't know what exactly the disconnect was, but back then, but we had gone through that debate a couple of times, unfortunately.
John, guarding the microphone. So one of the things that we're seeing is the development of general purpose APIs. So the same API being available across multiple resources, which was not something that people originally imagined when when OAuth was initially being developed. You had like a resource, and that single resource endpoint you could make up some custom scopes for. But now we have general scopes that could be used at your user info endpoint across 1,000 different user info endpoints, or health management scopes for fire, which are available across thousands of endpoints. So I think it is about time to sort of differentiate between the general concept of permissions that you're asking for and where you want to exercise those permissions. So I think that's part of OAuth kind of growing up, that having those sort of implicitly combined doesn't really work so well for us. I will say that I think that we do need implementation experience, but encouraging people to make the comments and feedback in some reasonable amount of time might be helped by moving it to working group last call, so that people know that we're serious about it. I'm getting questions from customers on a weekly basis saying, how come this isn't done yet? Please give it to us because I need it for this or that. So there's a lot of, out in the general community, there are people that are pushing, agitating for this. They're going to come up with other kludges that they're doing, horrible things that I can't even repeat in mixed company, to get around this not being a spec. So we need to, yes, we need implementation experience, but we also need to move this along and get people to provide the comments that are required to finish it off.
You asked why we didn't move the resource indicators forward. As far as I remember, it became obvious in a discussion that you can't discuss resources alone. You have to combine the resource with the scope. So what just John told us, you somehow have to tell where you want to go and what you want to do. So where you need this permission to be valid. And I think that's the point. It's not sufficient to just have a parameter which gives you the resources, which is totally decoupled from the scopes. Both have to be combined, which means you need a more complex parameter, potentially something structured. I think that's why we were reluctant to really adopt that. Reflecting on what John said, there is implementation experience available of how to combine resources and permissions, at least in our deployment. So we do it. We identify resources using resource servers using IDs or logical names, and we combine that with parameters. We encode that in the scope value because that's the only way we have seen, or we were able to implement that based on the current spec. I would very much like to have a more convenient scheme to really bring those two aspects together: the resource server and the permission on those resource servers.
What I heard back then in those discussions was that we already do these type of things with the resource indication, but we just dump it into scope, and that's why we don't need that parameter. And that's a comment I recall.
Right.
I understand that.
So yes, Torsten is correct. People do create horrible things where they create structured scopes that require parsing in various ways. Well, yours might not be, but I mean, I've seen Google and other people, create these sorts of structured scopes where you have key value pairs in them, which aren't really interoperable. So one of the things I might suggest is actually adopting the resource document as a starting point to actually have some of these more general discussions. So Brian and I brought that forward, but I don't think it was adopted as a working group document. Phil, who's softened subsequently on it, I think was digging in his heels, and Tony will probably still object, but I think that it's at least a good place where we can start the discussion.
So where does that leave us?
We'll
2 minutes.
Yeah, so we'll
Sit down.
discuss this resource indicator topic again at the next session, and also your next session, I mean, on Wednesday. So not at the next meeting, but I think it's something we should do another, give it another try. And also you had one other presentation which we need to push forward, given that we ran out of time. Maybe you can also update your slides because you had a couple of bugs on the token binding slides. Maybe could you fix them and send me an update? And I need the blue sheet. Who has the blue sheet? Who has not signed the blue sheet yet? Oh, right. We also didn't got to Thorsten's document, Thorsten, which is on agenda for Wednesday. Yeah.
So I would like to advertise the availability of a new document. It tries to cover all the open security issues around OAuth 2. And I would like to ask you to read the document and be prepared for discussion for Wednesday. Thanks.
Can I have the blue sheet?